Hello everyone, and welcome back to another video. Today we're going to be talking about two very important theorems in calculus. We're going to talk about the intermediate value theorem and the mean value theorem. They're very similar, and they're both very easy to understand, so hopefully you guys will leave this video with a complete understanding of them. To start with, the intermediate value theorem is extremely simple. Given a function that is continuous, very important that it's continuous, let's say a to b, so this is our interval, then there's a value assigned to each of those inputs, right, for our function f of a and f of b. All right, now the intermediate value theorem states that if f is continuous on the interval a to b, then for some value of the function, we'll call it the value of the function evaluated at c, so f of c, this is between f of b and between f of a. If f of c is between these two values, and it could be the other way around if f of a is greater than f of b, then there must exist some c between a and b, which will give this value. Now, that is a whole bunch of letters. There's not even a single number on here. So what the heck is all this jargon? Well, let's give you a nice and concrete example. Let's say our interval is 1 to 2. All right, that's easy enough. 1 to 2. All right, now let's say our function is x squared. X squared is in fact continuous on the interval from 1 to 2. So we have our f of 1, which is going to be 1, right? I'll write that down. F of x equals x squared. So f of 1 is 1 squared, so that's going to be 1. And then f of 2 is going to be 2 squared, which is 4. So then, we can pick any value between 1 and 4. Say it's 2. 2 is in fact between 1 and 4. Then there must be some value between 2 and 1, which will give us 2 when we put it into that equation, into our original function. In this case, that number is, of course, the square root of 2. Now, if we chose 5 here, then to get there, we'd need the square root of 5, which is not between 1 and 2. The whole idea of the intermediate value theorem is that there must be a value only for the values which are in between the two evaluated function values, right? This is f of 1, f of 2. Then there's a number that'll go inside the function between 1 and 2, the actual interval we're looking at, that'll get you there, right? All of these map to each other in the x squared function. And that's the intermediate value theorem. And I mean, this is pretty intuitive. If we have a graph that looks like this, and we know that this is a point and this is a point, and it's continuous, then we know that any value in between these two will have somewhere on the line or on the function where it reaches that. And that's pretty intuitive, right? But now let's talk about the mean value theorem. The mean value theorem is a little bit similar, so it's kind of easy to get it tripped up with the intermediate value theorem. But the mean value theorem, the key difference is that it deals with derivatives. Let's say we have a new function, g of x. All right, let's say we have an interval. We'll say 0 to 10. That's our interval. Then, if we take the average rate of change of the function, that would be g of 10 minus g of 0 over 10 minus 0, which is just 10. All right, so this is the average rate of change over that interval, 0 to 10, of g of x. This is just rise over run, right? It doesn't matter what the function actually looks like. It could look like this, but as long as the average rate of change looks like this, then we'll get our rise over run. So the idea of the mean value theorem is that this is the mean or average velocity or rate of change of the function over that interval. The theorem states that there must be some point on the interval where the velocity or rate of change of the function is exactly equal to this value. Basically saying that as long as the function is differentiable and continuous, then there will be some value c, where c is between 10 and 0, where the derivative evaluated at c will equal this average value. And that's the mean value theorem. So to recap, first we have the intermediate value theorem, which looks like this. And that's saying that if we have an f of a and an f of b, then if we're trying to find some f of c in between it, then there will be a value c in between a and b, which will give us that value. The mean value theorem, MVT, gives us that we have g of b minus g of a over b minus a to give us our average rate of change. I'll say VA, maybe velocity average. Then there must be some value c in between b and a such that c is equal to that VA. Now that may sound a little confusing for the mean value theorem, so I'll do one cemented problem with some real numbers, and then I'll send you on your way. Consider Usain Bolt running a race. He starts at, of course, 0 miles per hour. He's stationary. He eventually accelerates up to around 22 or 23, I believe, miles per hour, and then he slows down by the end of it because he's getting tired throughout the race. Maybe he's only at 19 or 20 by the end of it. So what that looks like by the graph of his velocity would be something like this. It goes way up, and then it starts to dip back down. Okay, so this is his velocity, right? So his position would actually look something like this. He hasn't moved at all, and then he's moving, and he's moving faster and faster until he starts to slow down a little bit, but he's always going forwards. So this is position. We'll call it just the normal f of x, and then this would be our f prime of x. So let's say he takes, 9.59 seconds, right? So we have our interval being from 0 to 9.59, and then our values are 0 to 23 miles per hour. That's his top speed. And that's looking at this graph right here, our f of x. Now, we know that the average velocity would be this over this, rise over run, right? Now, that value is 100 meters divided by 9.59 seconds. I guess that makes this in meters per second, so it should really be somewhere around 11. Now, this number, and you can easily verify this, is easily less than 11, but more than 0. So this lies in the interval from 0 to 11, and we know that had to be true because of the mean value theorem. Now, the application of this theorem would more likely be at what point is he actually moving that speed, but we can't ever try to solve that question without first proving that it actually is possible to solve, and by the mean value theorem, it is. Hopefully that wasn't too many random numbers and letters, and you actually understand the theorems that I've presented to you today. And as always, thank you so much for watching.